Welcome to this part. So you already know what embedded SIM is about. Okay, so we will not tell you what it is about. So together with my friend Alejandro, today we propose you to just think out of the box how embedded SIM could be used for non-telecom applications. All right. So we propose you first to introduce you with Valid. You may not know about us. So first of all, Valid, this year we are celebrating our 66th birthday. We are worldwide, okay, in different countries and continents, okay, for both R&D, sales, production. As a public company, our revenue is around 500 million US dollar per year. And we are 6,000 employees all over the world, not only in America, but in Europe and Asia as well. We are serving different businesses, identification, payment, mobile, of course, and data management. Okay, we are customer focused.
Yeah, and I'm also very proud to say that, well, Valid, we are the third largest ID and driver license manufacturer worldwide, the fifth largest SIM card manufacturer, also worldwide, of course, and the top 10 financial and prepaid cards, which is not that bad. And also we have presence globally. We are serving customers for 110 countries.
Exactly. So, why choosing Valid as a partner? So first, we are capable to port our secure operating system onto any security chip. Okay, first. Second, we are moving to digital, and as such, we have to adapt our business model, and we are licensing our secure operating system. Additionally, okay, we are focusing on customers, and we are offering to our customers to customize our operating system towards their needs.
Yep. Additionally to that, as we have the end-to-end process for the GSMA, for end-to-end for consumer, we also have some provisioning and personalization services that are, of course, GSMA certified. Also, we are, again, as Logan said, we are trying to think out of the box. So we also are providing some non-telecom use cases. So, for example, we have the automotive, integrated solutions, and also ID. And well, finally, and I think it's worth to mention nowadays, we are an autonomous and full independent player.
Okay, so let's move to your topic,
yep.
Alejandro.
So, well, we've been talking about the eSIM. I think we all know the eSIM, that's why we are here, okay? So, well, basically we think that the eSIM is a revolution, not an evolution of the SIM, because it changed how we work as Valid, as SIM manufacturer, we change everything. Also, the operators has changed also everything, and the device manufacturer has also changed everything. But also the end user has changed how they behave with the operator to get a subscription. So, well, this is thanks, of course, to the GSMA specification we've been working on. And, of course, this is because there is a huge security under this. So, well, basically, the operators that has the profiles and the credential, they are the owner of the credential to be authenticated to the network. So, they need to have a strong security on the eSIM. So basically for that, we have the SAS for the integrity and confidentiality of data, but also the security with the ESA owned schema from GSMA, and also the interoperability because the eSIM needs to behave as it's supposed to behave. So it's an eSIM. So, but this, I mean, those three topics those 3 points for the security are actually important because the eSIM is also able to run other applications, and we'll be commenting more about this. So with this we can say that actually the eSIM is the most secure element today. And did I say secure element? Yes. So the eSIM actually is a specific use case of the secure elements. So it's the heart of the eSIM ecosystem that we all know. And well, depending on the use case for the secure element, it can have similar security requirements for any secure element. So, regarding this, we can say that, Laurent?
Yes, one question for you. I've heard about embedded USCC. What is the difference?
Well, actually, the eSIM is the commercial name because it's much more beautiful than UICC, but are the same. So the eSIM is the commercial name, and the UICC is, let's say, the technological name. Yep.
Exactly.
So then, if we consider the eSIM as a secure element, specific for telecom, and if we are able to isolate totally the telecom part from the rest of the eSIM, and of course this part is compliance with the GSMA rules, and we ensuring the performance for everything that is inside the eSIM, we may think that we can use this eSIM for other use cases, for example, for wallets, for ID, and for secure credential storage. So, but here, okay, how the eSIM is running different applications. So first, to mention that the profile is not installed directly in the UICC or the eSIM, but it's installed inside the security domain. What is the security domain? Well, basically the security domain is a secure box inside the eSIM for operators not to expose the private data or the thing that they want to protect, actually. So actually, this security domain, because sometimes profiles contain applets, so actually this security domain is able to run applets because some profiles already contain applets. And well, can we use this technology for other issues, for other things? So right now, GSMA is also working in the secure application for mobile, which is taking this security domain concept for other use cases. But well, today is under definition, so it will take time to have it. But Laurent, can we leverage this security domain concept for other applications?
Yep. So let me introduce one solution. It is called StrongBots. You may have heard about, and I will explain. So first of all, if you are trying to simplify the architecture, you learn from Alejandro that profiles today are stored into security domains. And why not, okay, having a security domain dedicated for non-telecom applications, first. Second, such a security domain, reusing this global platform technology, would be able to run an applet that would be stored into this security domain.
Laurent,
yep.
May I ask, what is an applet?
So an applet, okay, it is a piece of software that is customized and developed in order to solve a use case, specific use case. Into our words, it is a Java card-based language. Okay, so there, the applet could be run into this security domain, okay, totally separately to the other security domains for telecom applications. So, StrongBots, you may have heard, it is a technology from Google, and it is a native functionality into Android since a while now, and it solves a security problem. It is a generic security problem. It is how to securely store keys that are used by Android applications. These keys could be used for different needs. One would be, okay, a secure key to encrypt files. Another could be to use a key to store and use a key to authenticate to a network, okay, etc., etc. So there are many use cases for these applications. StrongBots is introducing the notion of backward-backed key store. So key store is a native functionality within Android, right? And now Google is requiring that this key store would rely on a hardware security module. So hardware security module, it is what we were talking about. In that case, it is not exactly this one, okay? It is a tiny one. It is either a standalone security chip, okay, like secure element or even embedded SIM, and also a secure enclave into a system on chip. Right? And the requirement from Google is that this chip should be certified. Okay, common criteria EL4+.
Yeah, which is also a requirement from the eSIM.
Yep, exactly. Thank you. Google created an alliance with industry stakeholders that is called Android Ready SE. SE stands for Secure Element. And they are targeting to solve many use cases, so it is not an exhaustive list, but the first one, okay, would be how to securely store a file onto the flash memory of my handset. Okay. So the idea here is to encrypt and to decrypt with a secure key, which would be stored securely into a tamper-resistant element. Second would be how to securely identify a user and how to store these credentials into the flash memory of the handset. So Strongbot is answering this use case, storing these credentials into the tamper-resistant element. A third one, okay, could be how to use my cryptocurrency, right? Second is related to physical access control on how to open the door of my car, how to open the door of my house, or the office, or whatever. Okay, and another use case, but there are several others, it is related to electronic money, like wallets. So just to have a deeper view on the architecture. So you have two components into Strongbot's system. So on the right side, you can see the embedded SIM. On the left side, you can see Android operating system. So Valid implemented or preloaded an applet, the Strongbot applet called CleanMaster or CleanMind now. That is so now hosted, stored, and hosted into a security domain for non-Telecom application. Second component of the system is a hardware abstraction layer, which is a library, if you want, that would be integrated into the Android operating system. So you can see on the top the CleanStore API, which is a native functionality, a native API that is delivered into Android system. Okay, so what Valid is doing there is preloading the Strongbot applet into its embedded SIM. Second, the keys are provisioned during the embedded SIM manufacturing. And what the OEM is to do is simply to integrate the Valid hardware abstraction layer.
So I assume here that we will be guiding the OEM through this integration process.
Oh yes, of course. Yes, it is a difficult point. Okay, it is not as easy as integrating the library into a system. Okay, there are some parameters that needs to be initiated and populated into their system. Yeah. Just to show how it works, okay, into a Valid embedded SIM. So you can see on the left the Telecom part, and you can see on the right the non-Telecom part. So you can see on the left, okay, on the Telecom part, in that example, you have two profiles which are disabled, and on the left, only one is enabled. As you can see, each of these is isolated with a different security domain. And for the whole Telecom part, there is another security domain. So it is different security domains into one single security domain. So there is a double security level. And on the right, you can see two applets that are stored into a single security domain, the so-called non-Telecom security domain, So two applets, one is CleanMaster, CleanMind, and the second Weaver, which is dealing with with the screen unlocking of your device. Okay. Both of these are delivered by Google. Right? So today, valid embedded solution. So first of all, it is the first time that Strongbox is implemented into a non-secure element device. So today, main of the Strongbox implementation are based on a standalone secure element. And it is the first time that it is implemented onto an embedded SIM. And as you can see, so by using a non-Telecom security domain is ensuring that any telecom application is totally isolated from this non-Telecom application. So it is totally isolated, and it could be potentially a key by moving this Strongbox functionality from a secure element to the embedded SIM would be a way to remove from the device bill of material the secure element. So some conclusions. So you learned that an embedded SIM is a tamper-resistant device. It is proven security thanks to a third-party security scheme. So valid embedded SIM is featuring this all the security mechanisms, not only security domains, but it is really to make sure that telecom applications are fully isolated from the non-telecom applications. So valid embedded SIM is already preloaded with this Strongbox applet and all the keys. So today the product is available in mass production, okay, and there we are now following the Google roadmap. You know that Google is evolving every year, and Strongbox as well. Okay, so we are following the roadmap.
And yes, well, to finish, so I invite you to follow us on LinkedIn in the page there, and also to meet us in our booth, okay, in West Hall 1304. I don't read very well from here. And of course, we have a white paper that we've been working on, and it's already available there. If you scan the QR code, you will get this white paper that will explain deeply our technology. So thank you very much for attending.
Thank you.
And
questions? Any questions?
If there are some questions, of course.
Those days, we know that the device manufacturers use the UICC for the connectivity, and they have a separate secure element for banking, identity, and other type of application. So what do you think is going to be the main driver for those device manufacturers to move to the eSIM together with the secure application for mobile that you just explained?
So,
please.
Are you talking about SAM? So actually, well, I think this is different from where we are presenting here, because actually SAM is a much more complex technology that has the subscription manager for the SAM with all the applications that can be downloaded and so on. So per my understanding, this is an amazing technology, and it will be a super, it will ramp up the adoption of the eSIM technology. But I think today, I'm in the working group, so I know. So this technology will ramp up the adoption of the eSIM, as I said, but I think still we are far for the time to market is still very long. So,
Ken Kavanaugh and I were talking earlier about IoT and eSIM. I think eSIM is going to be a catalyst to finally get IoT to explode. What else is missing to be able to get these two technologies to really converge and move forward?
For the IoT,
for eSIM and IoT, to ensure that IoT really becomes
Okay.
An explosive.
Okay, so the IoT world is a very complex world, actually, because there are many entities that are playing different roles. So I think the eSIM for the IoT will be the option, the final option. I truly believe that. And we are working on this direction, so the IoT will be using the eSIM. The problem is today, in my opinion, okay, there is a misalignment between what the IoT, the different entities or actors of the IoT and the eSIM in itself. Okay, so let's see if the new Working Group 7 specification that are also from GSMA or proprietary solution as we have today, so it can solve this gap between the IoT needs and what the specification or the different products can provide.
I have a question regarding eSIM comparing to regular SIM. So regular SIM have vulnerability to swapping and cloning from a security standpoint. So how eSIM can solve that security vulnerability?
Okay, so the cloning was a problem in the SIM part, and today this is part. There is already some mechanism to avoid the cloning, of course. But I think the most powerful thing in the eSIM technology is the way the eSIM is communicating with the server. So actually, for the eSIM to be communicating with any server for the SNDP+, so need to have the GSMA credentials or a CI credential, and to achieve that, the eSIM has passed the functional testing and also the security testing, but also the place where the eSIM is produced is also certified. So this is a risk that in the classic SIM, from the classic SIM, we avoided in the eSIM. So regarding the specific cloning of a profile inside an eSIM, so far I haven't heard about. I don't know if it's possible, but actually the security certification we are through try to avoid this. So we have our countermeasures, we have the penetration testing, and actually when we certify a product, is to avoid this, to avoid anyone that is able to access to a profile and is able to take the network credentials to clone them. So actually, it's all the architecture is built to avoid this.
On the same lines, what are the advantages that eSIM has on top of iSIM from security perspective? Integrated SIM.
Well, actually, from our perspective, and regarding the new protection profile for specific for eSIM, E with eSIM and I with iSIM have similar security measures. So at the end, the secure enclave inside a SOC is already protected. And the measures there, the protection profile for this should be equivalent. Otherwise, I don't think the operators in GSMA would have allowed this.
Just to follow up, so if it's the same advantages, then why waste all that space on the device? Why not make it iSIM? iSIM needs such less space as compared to eSIM, right?
Sorry, I didn't get you.
The iSIM, integrated SIM, does not need a lot of space on the device as compared to eSIM.
No, but the technological complexity is there.
There is? Okay.
Yeah.